step-by-step form, but today I want to talk about special cases, the horizontal and vertical line. Notice this little table that I used from last time. It shows when to use a dashed line or a solid line. Dashed line when it's greater than or less than symbol, because points in that line are not going to be part of our solution, and solid line when it's greater than or equal to and less than or equal to, because points on the line are going to be part of our solution. I had a couple of sentences here which you can use. Inequalities was only x, use vertical lines. Equalities was only y, use horizontal lines. Let's see what that means. Before we graph, right, represent the area where all the y values are greater than 2, let's understand where y equals 2 is. Y equals 2 is this line. It's a horizontal line where all the y values are 2. So here is that line. And if you were to pick points on this line, right, any point on this line, right, you would have, for example, 2, 2, you have 3, 2, 4, 2, negative 1, 2. Every single point, the y value would be 2. That's this line here. But the inequality is asking us to show the region, because inequality, remember, it's point that the solution, right, to this inequality are points that may be on the line, and the region that's going to be either above the line or below the line, where all the y values are greater than 2. So first of all, let me take this out. It's this inequality symbol is greater than. So right off the bat, we should have used a dashed line, right? And that's what I'm going to do. So that's the dashed line. Let me just move it a little bit down there. And we want values. We want now to determine, is it the region above this line where all the y values are greater than 2, or is it below this line where all the values is greater than 2? So this one is easy, right? If you look, well, this right over here, the y value is 3, right over here the y value is 4, and so forth and so forth. But you can still pick a test point, and we're going to pick 0, 0 because it's not on the line. So remember, when we're doing a test point, we want to pick a point that's not on the line. Let's pick 0, 0. And in 0, 0, the y value is 0. And in this inequality, y is greater than 2. We substitute the y with 0 because 0 is greater than 2. And is 0 greater than 2? No, it's not. So the test point 0, 0 failed, and 0, 0 is under the line. So that tells us that the region where all the y values are greater than 2 is above this line, not including the points on the line. And there's our solution. Okay. Let's try another one. This one says x is less or equal to negative 3. So look at the sentence. Inequalities with only x, we're using vertical lines. So our lines are going to look like this. So the inequality is less than or equal to, so we know we're going to use a solid line. So let's look for x at negative 3. So it's a vertical line that goes through negative 3. And we're going to use a solid line. So negative 3 is right here. Okay, let me just move that line a little bit to the left. There we go. And every single point on this line, the x coordinate is negative 3, but I want x coordinates also that are less than negative 3. So they're either going to be on the left side of this line or on the right side of the line. So the points on the line are already solutions to that inequality. So pick a test point, 0, 0. And let's try that out. So my test point is 0, 0. It's not a point on the line. Remember, you want to pick a point that's not on the line, and if 0, 0 is available, use it. So here's my x value. This is my y value. My inequality is x less than negative 3. I'm going to use 0, right? So I'm going to replace it. And is that true? Is 0 less than negative 3? No, it's not. So the point 0, 0 failed to satisfy this inequality. So I don't want the side in which 0, 0 is, but rather I want the other side. And that is a side that every x value is less or equal to negative 3, including points on the line. Okay. Why don't you take a shot, do these two, okay, and pause the video, give it a shot, and then play it back again. All right, so y is greater than negative 1. We notice that the inequality sign is greater, so we're going to use a dashed line. And let's go to negative 1. So when inequality only has y, we're going to use a horizontal line. So find y is negative 1, which is right here. We can use a dashed line right there. Negative 1. Okay. And now the solutions are going to be the region above the line or below the line. We want values of y that are greater than -1. Well, obviously we can see that it's going to be up, but I want you to take a test point. Pick a point that's not on the line. 0, 0 is available, so I'm going to use it. This is my x and this is my y, so my inequality is y is greater than -1. Y in this case is 0. Is 0 greater than -1? Yes, it is. And 0, 0 passed and satisfied my inequality. So that means that 0, 0 is above the line. So that means that every point that's also above this line will make that inequality true. Okay, and that's our solution. The next one, x is greater or equal to 4. So that means that we're going to use a solid line first of all. So if you only see an inequality with x, we're going to use a vertical line. So let's look for 4 right here. We're going to solid line. So points on that line satisfy the inequality. And we want points, right, that we want to, shade the region that also have x values that are greater or equal to 4. So either they're going to be points that are on the right side or the left side of our line. So pick a test point. Well, these ones are easy. You really don't need to test point because we know that x values that are greater or equal to 4 are to the right of the line, but I'm going to do it anyway. So I'm going to take the test point 0, 0, right? 0, 0. This is my x value, this is my y value, here's my inequality, x is greater than 4, and I'm going to replace x with 0 and see if that satisfies the inequality. 0 is not greater or equal to 4, 0, 0, our test point 0, 0 failed, which means every point that's also on the same side of 0, 0, which is to the left of the line, will also fail. Oops. Will also fail, which means we want this side. Right? Those are the points. Any point to the right, any point on this side to the right of our line will have x values that are greater or equal to 4, including the points on the line. Okay, that's it.